Hi, this is Lakshmi. We shall discuss a little geometry today and solve an interesting Olympiad question at the end. The discussion progresses gradually towards the problem, so please don't skip the video directly to solve the Olympiad problem, just so to avoid any confusion. Geometry, the study of shapes, is one of the oldest fields in mathematics. It is originated to solve practical concerns such as measuring land, structures, etc. Now it appears in practically every aspect of this world. Geometry is crucial in designing buildings, bridges, and roads. The animation in computer games rely heavily on geometric transformations and coordinates, which is analytical geometry. Concepts of spherical geometry help in calculating distances and routes on the Earth's curved surface. Artists also use geometry. They use to create perspective, symmetry, and proportion in their work. By learning geometry, we will improve spatial reasoning, critical thinking, and problem solving skills. Geometry offers a powerful framework for understanding this world around us. Its concepts, tools, and intricate relationship between shapes, angles, and dimensions are used in various fields and everyday experiences. For now, let us focus on one very interesting topic of triangle geometry, which is medians. Median is a line segment that connects vertex of triangle to the midpoint of the opposite side. Vertex to the midpoint of the opposite side. So D is the midpoint of BC. Medians are always concurrent, and this property of medians is called as property of invariance. And all these medians meet at a point called centroid. It is also called the center of gravity of the triangle, which means we can balance a triangle at its centroid. Probably that is why it is represented by the letter G. Given the lengths of three medians of a triangle, using Apollonius theorem, we can not only identify the area of the triangle, but also identify the lengths of each side of the triangle. That means we can completely explain a triangle if we know the medians, length of medians. The centroid here, G, divide the median in the ratio 2:1 and lies closer to the base, obviously. And this median divides the circle into two triangles of equal area. That is, this median AD is dividing the triangle into two triangles, triangle ADB and triangle ADC. The area of these two triangles is equal and is equal to the half of the area of triangle ABC. Obviously, for both these triangles ADB and ADC, height is the same and is equal to that of the area of triangle ABC, and base is A by 2, A by 2. Right. So let us solve one simple question before diving deep into the Olympiad problem. This centroid G seems to be dividing the whole triangle into six regions, right? Even though they are not similar triangles, surprisingly, the area of all these triangles is equal and is equal to 1/6 of the area of triangle. To prove this, I have drawn two altitudes from point vertex A and the point G, which is centroid. Now we can observe the similar triangles, triangle AMD and triangle AND. So AM by AD should be equal to GN by GD. If we assume the height of the triangle as h and height of this smaller G and D triangle is H dash, and obviously this centroid divides the median in the ratio 2:1. So AM is H by AD is 3x, 2x plus x is equal to GN is H dash by GD is x. Therefore, H dash is equal to H by 3. So, area of triangle BDG is equal to BDG is equal to half of, this is midpoint, D is midpoint of BC. So, A by 2 into H by 3. Whereas area of triangle ABC is half AH. So, area of triangle BDG is area of triangle ABC by 6. Similarly, we can use the same logic and drop altitudes from other vertices to find out that each smaller triangle area is 1/6 of the area of triangle ABC. Since we have come so far, let me share with you one more beautiful property of centroid and medians. The medians and centroid of the triangle ABC are also the median and centroid of this inner triangle DEF, which is formed by joining the midpoints of sides of the triangle ABC. So, I will write the statement for you down, and then we'll explain, we'll try to prove the statement. Okay. So, the medians and centroid, the medians and centroid of triangle ABC are also the medians and centroid of the triangle DEF, and by induction also they are the medians and centroid of the triangle HIJ and so on, which are formed by joining midpoints of sides of triangle ABC. I am writing here HIJ is formed by joining the midpoints of triangle DEF and so on, right? Okay. Okay. So, all right. Let us see this triangle, right? If we assume the sides of the triangle are ABC, since D is the midpoint, BD is A by 2, DC is A by 2. Similarly, this is B by 2, B by 2. Here it is C by 2, C by 2, right? Now, for the triangle AFE is similar to triangle ABC, and clearly it is in the ratio 2:1, right? So the sides of AF and AE are half of that of AB and BC. So obviously FE has to be A by 2, right? So similarly we can prove that this side DE will be C by 2, and this side DF will be B by 2. So surprisingly, we have got here four similar triangles, right? From the bigger triangle ABC, we have got here four similar triangles, right? And all the four triangles have got lengths A by 2, B by 2, C by 2, right? And so the area of the triangle, let us say triangle DEF, area of this triangle will be 1/4 of the area of triangle ABC, right? Okay. Now, uh, now, so remember this one more point, and now we will come to the proof of medians and centroid are the same, right? So, for observe this a parallelogram. Uh, I mean, I am stating it a parallelogram because clearly BFED. This is a parallelogram because FE is equal to BD and BF is equal to DE. This is equal to C by 2 and this is equal to A by 2. So opposite sides are equal. So this is a parallelogram, right? And the point of intersection of diagonals bisect the diagonals in a parallelogram, right? So this point I here is the point of intersection of diagonals in the parallelogram BFED, right? So this is midpoint of uh, C, sorry, FD, right? So I is midpoint of FD. For the triangle DEF, for triangle DEF, this line EI is joining the vertex E to midpoint of FD. So the line EI, line segment EI is the median of the triangle DEF, right? Similarly, we can prove that this line segment is also the median of triangle DEF. Similarly, we can prove these other two lines DH and CJ are the medians of this DEH triangle and the point of intersection G is the centroid again. So similarly, we can prove that for this inner triangle also, HIJ also, these are the medians and G is the centroid. And not only this, even if we draw how many layers above it, the midpoints of this triangle or at any level we will go, all these triangles, the central triangles have got the same median and the same centroid. Wonderful, right? Now let us go solve the Olympiad problem. Let me read out the problem for you. Given a triangle ABC, E is the midpoint of AC and F is the midpoint of AB. Okay, the medians BE and CF join at G. All right. Y is the midpoint of BE. Okay, and Z is the midpoint of FC. Now we need to find the area of the inner triangle GYZ if the area of triangle ABC is 480. Sounds scary, right? Like, how can we even compare the area of this smaller triangle to that of this larger triangle? Yes, it sounds scary, but not until we understand the beauty of centroid and medians. Let us go ahead and solve it. So, this is the problem, right? Uh, Triangle ABC, and we have D. I mean, I have also added this median. D is the midpoint EF. So let me draw this triangle, right? So triangle DEF, okay, and another triangle HIJ. We have just now seen the beauty of medians and centroid in this relation. So now they don't want us to find out the area of this triangle DEF nor HIJ, but they want us to find out the triangle GIJ. Yes. Now it seems very easy, right? Because the area of triangle GIJ in this diagram, which is also GYZ, right? GIJ is equal to 2/6 of what? 2/6 of area of triangle HIJ. Why? Because the centroid G is dividing the HIJ triangle into 6 equal parts and GIJ is 2 of such triangles put together. So 2/6, which is 1/3. Now, how can we find the area of triangle HIJ? Triangle area of triangle HIJ is what? This HIJ triangle is dividing this bigger triangle DEF into 4 equal triangles, right? Uh, Equal area and they are similar also, same lengths, all the sides, right? So triangle HIJ is 1/4 that of area of triangle DEF. Okay. Now, how to find the area of triangle DEF? Triangle DEF is also 1/4 that of triangle ABC. And triangle ABC area they have given to us. Now area of triangle GIJ or GYZ, right, is equal to 1/3 of triangle HIJ is 1/4 of triangle DEF is 1/4 of ABC. Triangle area of triangle ABC. That means area of triangle ABC by 48 given triangle area is 480 by 48. So 10. That is the area of our triangle GYZ. Simple, right? In conclusion, medians exhibit remarkable properties of balance, concurrence, and area division, which we have just seen. Geometry is very critical in gaining spatial wisdom to see and understand the world around us in a deeper sense and gain uh, insights out of it. To learn geometry helps us gain critical thinking and problem solving skills. So practice this. Thank you so much for watching. I hope you find this session helpful and I hope it helped you increase your interest in geometry.